All right, so I wanted to take a look at the syllabus, see where we are. We're getting close to the end here. And so last couple weeks. So we are talking about exception handling today. And you do have an assignment and a quiz that goes with that. Let me pull that up on here. Okay. All right, so we have an assignment and a quiz, and then next week on April 28th, we're not going to be meeting. And the reason is because Java FX is 3 chapters that you'll need to read to be able to do the project. And I don't think you'll be able to read all 3 chapters by next Wednesday. So I wanted to give you some extra time to read it. So we'll meet the following week on May 5th to talk about the Java FX. And hopefully by that time you'll have had a chance to read over the chapters, look at the examples, and start thinking about what you want to do for your assignment. And then you'll have a couple of days to work on that assignment. You could even start working on it before we meet on Wednesday, and that way you can ask questions about it if you have questions. When you're working on this project and you're reading these chapters, if you don't want to wait till May 5th to talk to me about it, you can go ahead and schedule a Zoom appointment with me or send me an email. Send me what you have so far, ask if you're on the right track. I understand that maybe you don't want to wait till May 5th to meet with me. The other thing is, on May 5th, we'll also talk about the final exam for the class. So during final exam week, you will have a final exam. We will be using Honor Lock for the exam. Some of you may not have used that before. Have y'all used that?
I have. Yes.
You may have used it in another class. It makes sure that, on the quizzes, I let you use your notes and everything. But on the final exam, we're not using our notes or a book or anything. So it's going to monitor you, and we'll talk about this more detail in the next class, how Honor Lock works so that you can be set up for that. So when you're studying, the exam is multiple choice and true and false. When you're studying for the exam, I recommend that you go back through the quiz questions that we had throughout the class, that you go through the Kahoot that we did, because we did, practice questions on there as well. And you can even, when you're playing the video, you can't participate like we do in Kahoot. During class, you can't, it's not going to affect like the results or anything like that. But when you're playing through the video, you can try and answer it before we come up with the answer, or pause it so that you can see if you can figure it out before you see the answer. You probably don't remember the answers from each of the sessions. So that's good practice as well when you're practicing for the final exam. So we have to take it all the way back to variables and make sure that everything makes sense, because that will also, everything will be on the final exam. Okay. Now I don't have Java FX on there. I don't have a quiz on that, since we're pushing that to the last minute here. Also not on the final exam. Okay. So Java FX is just, you're going to prove that you read over it and it makes sense by doing the project, but you're not going to be tested on that. Okay. Any questions on that?
Is it gonna be like a multi-choice quiz? I mean, the final exam?
Yes, multiple choice and true and false.
Oh,
Kind of like the questions I asked you in the quiz, but don't expect the same questions. But don't
yes.
just memorize the answers to the questions, because that won't do any good. But go through and look at the questions, make sure you understand how to get the answer for the questions, because if you're asked a similar question, would you be able to answer that question? It'll have different data and it'll be worded differently, but if you understand, the questions that are on there, maybe even do some of the checkpoint questions in the book, to make sure in each of the chapters, make sure you're okay with that chapter. But focus on the chapters that are a little tougher too. If you're already really good at loops, then just make sure you skim that and skim the quiz, but spend more time on the ones that aren't as, don't make as much
Gotcha.
sense. Okay. All right. So everybody good on that? We'll talk more about that next week, but I wanted you to have some idea of what to expect, because it is coming up, but not next week, the following week, May 5th. But do schedule an appointment to meet with me if you do have questions. If you're writing down a bunch of questions and you want to meet with me, just schedule an appointment. I'd be happy to meet with you. Okay, well, let's go ahead and play our Kahoot game and see how well this chapter made sense. It takes a while to load sometimes. I already took attendance, so I marked down everyone that was here. So, but I'll do it again later if make sure I got everybody. Okay, so the pin is 1621605. Okay, let's get started. And if anyone's joining late, you can still join. The pin will be at the bottom. Okay, so actually the catch clause does all of them. So it always follows the track clause that has to come first. Contains code to gracefully handle the exception type in the parameter list. Yeah, that's true. And is followed by a parameter list containing the exception type. That's true as well. So all of them are actually true. Okay, so we got a split one on this one. So let's look at the code. So here you have an array that's empty. So you can do the length of the array and you won't have anything, it'll be 0, but you can't really say name index 0 because you don't really have an index location 0, it's empty. So when you go to say name index 0, you're going to get an array index out of bounds exception because there's no value there. So you may have gotten this before. How many of you have seen this error before?
I think so.
It maybe at some point, sometimes what happens is when you're working with a loop, if you say that you want to go to less than equal to the length of the array, for example, sometimes that happens instead of less than the length of the array. So let's say you had 10 values and you go less than equal to 10, it'll include index location 10. But because arrays start counting at 0, there is no index location 10. So when it gets to index location 10, it'll give you this exception, array index out of bounds exception, which means you've gone too far. It doesn't exist.
That was one of my first exceptions to actually run across because I didn't know about the. I started Java separate from the class, and so I was kind of just messing around. And what do you know? There's the index exception, and I'm like, how did my array give me an exception? Is it supposed to count from 1?
That's good. Yeah, it does. If you go too far, it doesn't know what to pull because it doesn't have a value there. So that's why it can't do it. Now, sometimes what'll happen is if you have like an array has 10 values, but you only go to index location 5, for example, by mistake. Let's say it used to have 5 and you go to less than 5 instead of less than 10. It won't tell you that you haven't gone far enough to get all the values. So you have to be careful. Just because it works, you may not have pulled all the values out if you have the wrong length. Now that's why it's good to use the name of the array.length because then you get the exact length instead of actually using a number like 5, because if you change the number of scores or whatever's in your array, then you might forget to change that number, and then it might either be too far or not far enough. So you have to be careful. It doesn't tell you about not going too far, but it does tell you about going too far. It doesn't tell you about not going far enough, but it does tell you about going too far. Does that make sense to everybody?
Yep.
Okay. All right, so let's see how we did. Okay, good. Okay, so this was a tough one, and I can see based on the answers all over the place that this, is a hard concept. So you have something known as checked and unchecked exceptions. Okay, so checked exceptions are the ones that you must handle. Okay, so you usually put the throws clause in the method header. And the reason why you do that is because there's some things that you do in Java that Java won't let you go because it knows it's possible it can throw an exception. You want to handle it. Like, for example, found not found exception. If you're working with files, you're going to want to put the throws found not found exception in any code that's working with files. Like if you're going to plan it on open files, it knows it's possible it might not find that file. And so it wants you to have that exception listed. Now, that's a checked exception, which means you have to handle it. But then there's unchecked exceptions. So unchecked exceptions are anything that comes from the error class, which could be something that you can't fix, like the processor. If it's coming from the error class, that's something you can't really deal with. And other ones are the runtime exception. So runtime exceptions could be like array index out of bounds. It could be like number format exception if you're trying to take a string and parse it to an integer, for example. It could be arithmetic exception. You're trying to divide by 0. Those are examples of runtime exception class. And you might be saying, well, shouldn't I handle those? I think you should. Like, depending on what you're doing, I think you should. It's better to do something about it than to just let it, halt the program and print something on the output screen. You can choose how you want to handle it, but you're not required. So like if you've seen that array index out of bounds error before, because you're not required to handle it. So if you put an array in there, Java doesn't make you put error handling in there, exception handling in there. So it's up to you if you want to put it in there or not put it in there. So the unchecked, you don't have to handle, but you can. And the checked you do have to handle. Does that make sense?
Mm-hmm.
Okay, perfect. So just think checked, like you have to do, like check it. Unchecked, you don't have to do. If you had a checklist, you have to get the checked ones. Okay, if that helps. Okay, so what happens, you've probably seen these before. You've seen the array index out of bounds. You probably have seen number format exception. So sometimes this happens to me whenever we do JOP Champagne, which we do a lot in here, and you have to type in a number into the box. Sometimes I type in a number, accidentally hit like spacebar or something, another character that's not a number, and you hit enter. What happens is it prints at the bottom, it stops the program, and it prints at the bottom number format exception. That means you hit a character that cannot be converted to an integer, so it stopped the program. Okay, so this one, program is halted and default exception handler handles the exception. That's what that is when it's printing down in the output box. It stops the program and it prints for you. So if you don't want it to do that, you can handle it yourself. And maybe as an example, and I'm going to show you today, and when someone's entering data and they enter something that can't be parsed to a double or an int, maybe you let them enter it again instead of just stopping the program like Java does by default and printing the error. maybe you let them do it again. So it's things you want to think about. How can I structure this program so it doesn't, crash and print something? Okay. Because the user might not pay attention to directions. So it's good to have added things in there to help fix that. And that's what this chapter is all about. Okay, good. So whenever you're doing a checked exception, you're going to write that throws clause and the method header. So it knows that that code can possibly cause problems because checked has to be handled, remember. Okay, so that word cannot may have thrown you off. Be careful with that word. It is possible to have more than one catch clause per try statement. So really what you do is you put all the code that might cause problems in a try, and then you put a catch on there, but you can have multiple catches if you want to. So you can be specific. So let's say that in your code, you might have something that can cause a number format exception, which is when you're trying to parse. Anytime you're trying to parse the data, you can have a number format exception that would be a catch on your try, right? But then maybe also you have an equation on your try, and maybe that equation could have problems. If you're asking the user for numbers and they enter data that could cause problems with arithmetic, then you might want to have an arithmetic exception, okay? So why would you have multiple exceptions? Well, it's only going to match the one that's true. So if you have an arithmetic exception and you only have a number format exception listed, then it's not going to match it because it's not the right type of exception. So some people say, well, why don't I just put exception down there? Like there's a generic exception instead of being specific and saying number format exception, arithmetic exception. Why don't I just say exception and just do one catch and it catches everything? That's fine, except that you can't tailor your error message or whatever you're doing, whatever you want to do in the case that it is an error, because it's generic. So you would do something different if it was an arithmetic exception versus if it's a number format exception or array index out of bounds exception. So you would handle it differently. So that's why you have separate exceptions for the different cases that it could be. And then that way you can do different things in each of the catches based on what type of exception is. Now, what you can do at the end, you can put like number format exception, arithmetic exception, and you do different catches for each one. And then you can always do a catch at the bottom that would just say exception. And then you could just put in there error or, loop it again, whatever you wanted to do in there to handle everything, because the exception, the general one, will handle all the exceptions, but you can't be specific in that one and do something specific because it handles everything. Does that make sense to everybody? Okay, perfect. Great. Okay, yes. You're not required to catch exceptions from the runtime exception class because those are unchecked exceptions. So remember, the unchecked exceptions are the error class and the runtime exception class. So you don't have to handle those. I think it's beneficial if you do, but you're not required as far as running your programs. But can still cause problems. Just means that in order to run it, you don't have to put the throws on there to handle it. Okay. So let's see how we did. I always like the names that everybody comes up with. All right, good job, everyone.
Student got 5th place. That's pretty good.
Okay, let me bring up a basic example to start off with. Make sure everybody's okay with that. So let's bring this up because this is something we do all the time. Now, I should have probably put J-option-P in here, but you can imagine if I put J-option-P in here. We do this all the time. We try and parse a string and put it in a number. But the problem with this is if you try and parse a string that can't be changed to an integer, then you're going to have an exception thrown, right? So if you were to do this, something like this would happen. You've probably seen something like this happen before. This is the number format exception. Okay. And that's whenever you try and parse something that's a string to an integer, for example, or a double, and it can't do it because it's not that type. It can't convert like A, B, C, D, E to be an integer, so it has problems. It doesn't know how to do that, so it throws an exception. Okay, so there's a better way to do that. Does everybody see the problem with that? That's it. That's not handling it because that's a unchecked exception. You don't have to handle it, but this is what happens if you don't. Okay. So here's one way to handle it, but this is a basic way to handle it. So here's the try. The try is any code that might have problems. So this part isn't going to have problems. This part is fine, but this part where you're parsing to an integer is the line that's going to have an issue because if it can't parse to an integer, then it's going to throw an exception, and then that's what you're going to see down the bottom. So you put any code that might have a problem inside the curly braces of the try, and the catch is specifically what type of exception that you want to deal with. So number format exception is the one where you're parsing. Again, I could put a generic exception, and that would be fine, especially for this particular thing that I'm doing here. Or you could get specific with it. So if there was something else in here with like arithmetic and that was the problem, this wouldn't actually happen because it didn't say, you know, exception or arithmetic exception. It specifically says number format exception, so it only works for that. But that's all I have in here is this bit. So this is what would happen. It does kind of the same thing except all the red. Instead it says conversion error here, which does get specific because you are converting. And then it tells you what the conversion error is. Okay. So there is a, whatever you want to name this, most people just call it E, the name of the object, and then you just say e.getMessage. It will give you what the problem is. So you can just do a basic printout of the problem. That doesn't really help though, because if you're doing like J-option-P and they're entering data, well, now they know what the problem is, but now they need to run the program again to get it to work. It might be better to just let them do it again. So that's what I want to show you in the next one. But before I do that, is everybody okay so far?
Yes.
Okay, so let's say we wanted to do J-option-P. This is what I normally do. So here we have, actually, I want to do this one. Sorry, we'll go to that one. Just, where is it? Should I name them differently? Here. I'm going to do the loop first, and then we'll do the recursion. So here I have J-option-P. So here I have a method. I'm calling the method getNumber and putting it in a number. So the purpose of this method is to basically determine if it is an integer. Okay. So what we have is we have this Boolean flag, and while the Boolean is true, so here's a loop from here to here. Okay. So here I have them enter a number, right? This isn't the part that's going to cause problems because anything they enter is a string. So that's not going to cause any exceptions because you can enter any character you want and that's fine. You can put space, you can put periods, you can put numbers, you can put letters, it doesn't matter. Okay. But this is the part that's going to cause problems because whenever it tries to take that string and create an integer based on that, you're going to have problems. Okay. So if you typed in any letters that can't be converted to an integer, this part is going to make the catch happen. So because this isn't a try, it's going to go to the catch. And you have number format exception because that's the type of problem you'll have. And it'll print the message, okay? But the cool thing about this is, what happens after it prints the message? So let's say you enter A. Okay, so it's going to print that there's a problem with that, okay? But what's going to happen is, it's going to go back to this loop again because the flag is still true. And it's going to go and ask you for a number again, okay? And it's going to try and parse it. The only way to get past this line and make it to this flag variable set to false is to not go to the catch. If you get thrown to the catch because there's an exception, then you never set the flag to false, which means the loop never stops. So until you enter a valid integer, you will not make it to this line and this loop will not stop. So let's see. We type in a string. Nope. And it says there's a problem with that. Okay, type in a string. Nope. 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 Okay, let's type in a number. Okay, we're good. So it's a way of preventing someone from doing data that's incorrect. And then once you do finally get to stop the loop, which goes from here to here, then you return the number and that goes back and gets saved in here so you can finish whatever else you wanted to do with that number once you know it's an integer. Everybody okay with that?
Yep.
Yes.
You're good?
Makes sense to me.
Okay, perfect. So the one I wanted to show you, this is the one I actually like, but you'll pick which way works for you. So there's something called recursion, and we haven't talked about it yet, and you actually will talk about it in more depth in the next class. If you take the COSC 2436, the data structures, recursion is part of that class, but it's kind of an easy concept to get. It's really not that bad. Recursion is the process of calling a method from within itself, okay? So why in the world would you want to call a method from within itself? Because it won't just keep going forever? Well, you have to be careful with it, that it doesn't do that. So in this one, this code looks the same. You have this in the main method. This, you have a get number method just like before. This is the same. This, you can see you have the message up here, taking in a string message variable. So here I have it in the try just like before, except I don't have a loop this time. So the difference is if there's a problem here, it'll go to the catch. And what we'll do, it will print the error message. And then what we'll do, it will call the get number method again, which is right up here. So it'll force it to do all this again. Okay. So this is recursion. See, it's actually telling me get number will recur infinitely, which means it won't stop. So you have to have a way of getting your code around it. NetBeans warns you about recursion because sometimes people do it accidentally. So recursion can be used to be helpful, but sometimes people can do it accidentally and it can cause problems. So I did want to do it on purpose, so I'm going to leave that there. But it's only going to call the method again if it's in the catch, though. So if it gets past this point here, it's not going into the catch, so it won't call the method again. So it'll return the number. So once it gets past this, it goes to here. But if it gets stuck here, it goes here and it calls it again and tries again. So it's a loop in its own way. I think it's a little bit less code though, so I like it a little bit better. But it does the same thing. It's just a loop that keeps repeating itself. And when you finally enter something that's okay, it doesn't go to the catch, it doesn't call itself, and it returns the number. Pretty cool, right?
You have a question in the chat from
Number-
Matt J.
Where a number format exception and E defined. Oh, there number format exception is a class that's already written for you. You don't have to, the way it's written, you don't have to when you do a catch like that, you don't have to create like a number format object the way you normally do. The try catch is written so that you can put it in one of the exceptions that exist in there and it knows how to handle it. So there's a number format exception class out there. So you are creating a number format exception object here called E. Whenever it throws the exception, it saves that in E, and then you use that when you say E.getMessage, it gets that. So whenever it throws the exception, it knows to save that in this object type. And if you go out there under the Java Lang package, you can see all the different types of exception classes. I'm trying to see the chat. You Google recursion. That's funny.
I think someone else had a question. Their microphone is just low.
I didn't, yeah, I heard something. I wasn't sure if it was background or if someone had a question.
Yes, I have a question. I'm not sure if my mic's working okay.
Oh, we can hear you.
You can hear me?
Yes.
Okay, so every time we create a try and catch statement, uh, if we don't have any problem with our code, it's not gonna go to the catch, right? It's just gonna go to the try and then keep going.
Right, exactly. So it'll only do what's in the try and then it'll skip, it won't do the catch. So
It'll skip the
you
catch.
can have multiple catches, it'll skip all of them. Like, and if you put different types of catches, whenever there's an exception in the try, it'll match up the exception that matches whatever type of exception you had. And that's why if you put like a general exception at the end, it might be good because that way if you forgot one of them, if you missed one of them, you have something at the end that it can match in the case
And
that you
and
didn't
if you
catch.
have two catches and then you have two exceptions matching both, it'll go through both.
It'll if you had sorry, say that again. I was reading the chat. I'm sorry.
If I have two catches and then my code has two exceptions, will it go through both catches?
It will look at the different types of exceptions you have. And when you ever try whatever type of exceptions thrown, it'll go look at the different types of exceptions to see which one matches. But if you have more than one the catch that goes with the try, it'll look at those catches. So like if you have a number format exception and you have an arithmetic exception and you have an array out of bounds exception, depending on what caused the problem in your code, it'll match the right exception. But if you put a generic exception, like instead of putting number format exception, I could just put exception here. That's fine. It's just that, and it's going to warn you, but it's fine to put there because any problem you have will go to exception. It's just that it's saying maybe you don't want to do the same thing for every problem you might have. And if you do this, it's going to catch anything. And maybe you want to have separate exceptions for each one that's actually more specified, more specific than just exception. That's what it's saying. So it's better. It's saying it's better to catch each individual exception so you can cater it than to have one generic one.
Got it. Thank you.
Yeah, I think you can nest them inside of each other. You just whatever. It's just like ifs and else's. Like if you have a try, it'll go to the catch that's lined up with that one. Okay. So I think I changed that, so that's why it's complaining. But okay. Let me pull up something. There's two ways of doing this. There's a basic way and there's a little more advanced way. So let me pull up, this one's a little easier. So your book talks about writing your own exceptions. Okay. And it also talks about using like the illegal argument exception. So I want to show you this way first, okay? And then I want to show you how to write your own if you want to. So there's this bank account file. And in the bank account file, basically, if you're getting a negative balance, that would be bad, right? So in the constructor for the bank account, whenever you pass in the balance, you're going to check to see if the balance is less than 0. And if the balance is less than 0, there's an exception called a legal argument exception. And so if you do something like this, throw new illegal argument exception, you can cause it to actually, print this balance for you. And then otherwise, you want to set the balance at the starting balance. But if it's negative, you don't want to set it at the starting balance. You want to throw this. Actually, you're going to set it either way, I guess. But no, actually, when you do the exception, if you have it, it won't set it because it'll error out. So, but you could put that as an else too. All right, so let's see here. So you have your try, you have your bank account, you have a negative number, and that's a problem, right? Because you shouldn't have negative numbers in there. And so then you have a catch and use the legal argument exception. So whenever if you wanted to write like your own criteria for your catch, you just put a conditional and then you put like what you want to throw new illegal argument exception, and what do you want to print out. And then when you do it, whenever it catches it, it'll do that so that it'll say invalid balance is negative 100. Okay. So that's one way, right? Now this, actually, I didn't take this off of here because I tried to condense it. That comment is incorrect. Ignore that, sorry. We're using the legal argument exception. That's one way to do it. And your book actually talks about this on page 726 and 727. Talks about the illegal argument exception, which is what I just have here with a different example. Your book talks about one with the dice. Like if you wanted to have a certain number of sides on a dice, and they entered too many sides, it would do the legal argument exception. This one talks about like a negative bank account. You don't want to have that either, so that would, you would write an if statement to let it not be less than 0. So it's just saying, like, how do you write your own conditions, basically, that throw exceptions? So you can also, if you wanted to, write your own class for it, and that's what that comment came from. Sorry, because this is the same idea, except it's just a different way of doing it. So you have the bank account in here, and in the bank account, instead of doing the illegal argument exception, you can do this negative starting balance. But if you're going to do that, Java doesn't know what the negative starting balance is, so you have to write your own class for it. And if you're going to write your own exception class, you have to extend the exception so it knows how to do that. And then what you do is you just, you can call like the super that does the exception and pass it whatever different messages you want. Like for example, this one just prints a basic one because it doesn't have the balance. And this constructor has the balance, so it prints the balance as well. Does it, same thing, except this one has the balance. And so it looks kind of the same, except instead of a legal argument exception, you have the negative starting balance. So if you wanted to create your own exceptions, you could create your own class that extends exception, and then you wouldn't have to use one that Java has, right? Because you can't just throw whatever kind of exception you want, right? But you can use one that they have, or you can create one of your own. So that's just another way of doing it. This one causes a little more work than the other way that I showed you. And here's the right comment for this program. So it's the same idea. And again, on your book on page 726 and 727, talks about the DICE program and how to do the legal argument exception with that. Okay? Everybody okay?
Yeah, I think so.
Perfect. Okay, so what I want to do is I want to bring up a problem for you. Now, on Canvas, under modules, I'm not sure if you noticed because I just did it last night. I was thinking that I can post a file in the breakout session or in Zoom, but it seems like if I want to do that, I have to put it in the cloud and everything and get it off there. So I thought it might be easier just to post it on here. So here you have this test scores.zip, and I'll read the chat in just a second while everyone's going to get this. So if you haven't gone onto Canvas and gotten this file, please do so now. And you'll just, when you download this, if you could just unzip it. I have it set up to be a NetBeans project. So if you have NetBeans, you can easily open the project, and you're just going to add a constructor, which I'll talk about in just a second. But if you don't have NetBeans, you can copy the Java files into like Eclipse or whatever you want to use to run your code, Visual Studio. But go ahead and get that code from Canvas for me, because we're going to use that in the breakout session. Okay, and then I'll read the chat and see what's going on over here. There's quite some text here. So Matt, I'm not actually sure. I've never tried to like nest tries inside of each other, if that would. I'll have to look into that. And you can have multiple catches to do what you want to do and everything, but I don't know. It seems like maybe if you had an inner try, it wouldn't really know which try to catch it with, maybe. Okay, so here's what it says. when a try catch block is present in another try block, then it is called the nested try catch block. Every time a try block does not have a catch handler for a particular exception, then the catch blocks of the parent try are inspected for that exception. If match is found, then the catch block executes. Does that help? You can. That was right with my first instinct. I just don't do it. Okay, so did everybody get it from Canvas?
Yeah, I got it.
Okay, so here is what I want you to try to do in your breakout group. There's 2 files on there. You're going to go to the test scores class, and there's a missing constructor on there. I'll show you in just a second where you're going to put your code. And so you're going to add the constructor for it. And this constructor should have a parameter of an array. Okay. And then you're going to check that array that's coming in. And you're going to see if the values are negative or greater than 100. They shouldn't be. Okay. So if they are, you're going to throw an illegal argument exception, which if you need a reference on page 726 and 727 in your book, the die program I was just talking about. And also don't copy these values into the scores array. So let me show you what this looks like. I liked this one because it was in black so you could see a little better. I could change my NetBeans setting, but in NetBeans the comments are gray. So, and I kind of like that, but it's a little harder to read. So I don't know if you can see that or not, but basically there's a scores array up here that's already done for you. Okay. And what you're going to do down here, here's what I want you to do. I have a description of it. Up here, I do have the Javadoc notation for it, but then here is what I want you to do, just explained, just like I had in the breakout explanation I just showed you. So I want you to write a constructor here that takes in an array. Okay. Now, one of the things you're going to want to do is you're going to want to set the length of the scores array is one of the first things you do because it never gets set here. So it doesn't know the length of it here. So in your constructor, the first thing you should do is set the length of the scores array based on the array that's coming into the constructor. Okay. Then figure out a loop to loop through your array and then do your conditional to see if it's out of range that I have listed. So it shouldn't be negative and it shouldn't be greater than 100. And if it is, you're going to throw that illegal argument exception. Otherwise, you're going to copy it into the scores array. Does that make sense to everybody?
Yes.
A little bit? Okay.
Yeah, kinda.
Kind of. It's a lot to take in. So first things first, write the basic constructor that takes in an array. Second step, set the length of the scores array based on the array that comes in. Third step, write your loop that goes through the array. Fourth step is to write the conditionals that throws the exception and copies the scores into the array. Okay. So kind of do it step by step and then maybe I'll help. Okay. So I'm going to stop recording.